one of the interesting things that you can do now that you understand the ideas or the basic principles of inverse trig functions is that you can use them in the relationship to right triangles to draw interesting inferences about whether or not you're dealing with sines or regular cosines. So really what I'm trying to say is something like y equals arcsine of x. If you know that y equals arcsine of x, you can actually develop other relationships for things like cosine, cotangent, cosecant of y, just because you have the relationship of these two variables. And the way we're going to do that is using the right triangle trig. This is a really important skill, more important than it seems on the outset, because you're going to be able to use this technique for something called trigonometric substitution for integration. And there are plenty of tables and plenty of things to look up for trigonometric substitution, but I find personally that I don't have to remember those. I can remember this methodology, and anytime I see arbitrary integrals like that, I can use this substitution without having to reference a table. It's just easier to remember for me. So let's get to it. If I know that y equals arcsine of x, what I know then is that sine of y equals x for some restricted values, right? Y has to be restricted from negative pi over 2 to pi over 2. And that's okay because we're dealing with a triangle. So we have to be a little bit careful because if you think about this for an angle on a right triangle, negative pi over 2 doesn't really make sense. But if we think about it for a right triangle, you're pretty much not going to have a right triangle that's not got first quadrant values for. In fact, you're not going to have it for ones that don't have first quadrant values for the other two angles. Anyway, the methodology goes like this. This is all you have to do. Is that if you have this, instead of writing it like that, do one small tweak. Write it as a fraction. You say sine of y is x over 1. So if it wasn't already a fraction, like if this was like arcsine of x over 2, it'd be okay. You'd already have it. Here's x over 2. But if it's not written as a fraction, write it as a fraction, and then you know that sine is the opposite over the hypotenuse. That's the definition of sine. So if you have those two things, then this goes on the opposite side, that goes on the hypotenuse. So you construct a triangle. Put y, you could put y in either corner. I typically put it in the bottom left corner. But I take this and I say, okay, I know that my opposite side of my angle is x, and I know that my hypotenuse is 1. Okay, so all you have to do now is fill out this piece. But it's a right triangle, so you have the Pythagorean theorem at your disposal. So something squared plus x squared equals 1 squared. So that's something squared plus x squared equals 1. Whatever goes here, we don't know yet. So that something squared is 1 minus x squared. So then we take the square root, and that something is the square root of 1 minus x squared. Now you might say, okay, what about this plus or minus? Well, in this case, we're dealing with a triangle, so those are lengths, so you wouldn't have a negative case there. So you'd say, okay, 1 minus x squared. So this is now my triangle. I have it filled out, and as a result, I can immediately go to here and draw the inferences I need to draw and come up with the expression I need. So in the case of cosine of y, what we know is cosine is the adjacent side over the hypotenuse. So I say, okay, well the adjacent side is this. It's 1 minus x squared. The hypotenuse is 1. So my expression is the square root of 1 minus x squared. And that's it. That's how you do that problem. For this one, it's similar. You just have to remember what cotangent is. Now, most people don't remember cotangent, but it's easier to remember tangent and then flip it. Since tangent is opposite over adjacent, then what we know is that cotangent is adjacent over opposite. And we know that the adjacent side is the square root of 1 minus x squared. The opposite side is x. And that's our answer. So realistically, the hardest part is constructing the triangle. Everything else is pretty much straightforward once you have it.